Okay, welcome to Let's Get to the Marks. We're looking at the preparation of hexanol from hexene, so electrophilic addition of alkenes to form an alcohol. We're also going to do some yield calculations. The question is about the preparation of hexane-2-ol. Hexane-2-ol does not mix with water, it's immiscible, essentially, and has a boiling point of 140 degrees. Hexane-2-ol can be prepared from hex-1-ene using this method. Measure out 11 centimeter cubed of hex-1-ene into a boiling tube in an ice bath. Carefully add 5 centimeter cubed of concentrated phosphoric acid to the hex-1-ene. After 5 minutes, add 10 centimeter cubed of distilled water to the mixture and transfer the boiling tube contents to a separating funnel. So you're looking to get rid of those impurities that are soluble. Shake the mixture, allow it to settle, discard the lower aqueous layer, add a fresh 10 centimeter cube sample of distilled water and repeat the steps D and E. Transfer the remaining liquid to a beaker, add 2 grams of anhydrous magnesium sulfate and allow it to stand for 5 minutes. Filter the mixture under reduced pressure, distill the filtrate and collect the distillate that boils in a range of 130 to 160 degrees. Let's get to the questions. 5.1. It's important to wear eye protection and a lab coat when completing this experiment. So we can't write those down as answers. Suggest with one reason another appropriate safety precaution for this experiment. Well, you remember we're using phosphoric acid. So wear gloves because phosphoric acid is corrosive. You also might want to use a fume cupboard. When you're dealing with organic solvents or organic chemicals or compounds, they're volatile. They vaporize easily and can form toxic fumes. So this should be done in a fume cupboard as well. Give a reason for adding the distilled water in steps C and F. So why do you add distilled water? Well, the distilled water will dissolve any soluble impurities, things that can dissolve in water. You can then get rid of the aqueous layer. So distilled water dissolves soluble impurities. That's your answer for 5.2. Let's look at 5.3. Make sure you pause the video before each of these and have a go. Give a reason for adding anhydrous magnesium sulfate in step H. What does anhydrous mean? It means without water, dry. So this is a drying agent. It's going to absorb water really well. So it's going to dry out your product and remove any of that distilled water that's left behind after it's been removed. So it's a drying agent. It removes water. Now we're on to 5.4. Complete and label the diagram of the apparatus that is used to filter the mixture under reduced pressure in step I. So you need to know about this apparatus for filtration. And the first thing we're going to add is a Buchner funnel, okay, which I've badly drawn here, and you'll score some marks for the labeling of this because it does say we need to label the apparatus, label the diagram. So you've got a Buchner funnel. A Buchner funnel naturally has a ceramic plate in it, but you also place moist filter paper in there as well, and then your solid is going to go on top of the moist filter paper. So you need to get these marks, you need to have labeled the Buchner funnel, the moist filter paper, and put some sort of bung into the end of the pump, of the conical flask, sorry. And that's really all you need. And the solid just goes in above the filter paper. Don't draw like my solid I've done here. I've messed it up. It shouldn't be poking through the filter paper. So that's a bit of an error there. So don't worry about that. But what do you need for the marks? You need the Buchner funnel, some filter paper, and the bung, and all of them labeled. Identify the most likely inorganic impurity other than hex-1-ene in the distillate collected in step J. So obviously hex-1-ene was our starting reactant and hexane-2-ol was our product. Other than the leftover reactant that hasn't been got rid of, what's the other likely impurity? Remember, during electrophilic addition of alkenes, we can form 2 possible carbocations. This is the less stable one formed, and this is going to form hexane-1-ol as a minor product. Okay, so you're going to get some hexane-1-ol formed. I worry about my spelling of hexane-1-ol. There shouldn't be a hyphen between the hex and the "an" there. Sorry about that. Now, why is it difficult to separate hexane-1-ol from hexane-2-ol? Well, they've got the same mass. They're going to have the same type of hydrogen bonding because of the alcohol group. So they've got a similar boiling point, same physical properties, similar boiling point. So very difficult to separate from each other by distillation. Okay, let's look at 5.6. Calculate the mass in grams of hexane-2-ol formed from 11 centimeter cubed of Hex1ene if the yield is 31%. Give the answer to one decimal place, and we know the density of Hex1ene is 0.678 gram per centimeter cubed. So you're going to need the density calculation. You should be triggered by seeing the density word there. So D equals M over V. You're also going to need the yield calculation. So we want actual mass over theoretical mass times 100 equals the yield. And here they've actually given us the yield, but we're missing that actual mass, and that's what we want to. We want to basically find the actual mass. So the first thing to do is work out our mass of Hex1ene that we have. So we're going to use the 11 centimeter cubed and the 0.678 gram per centimeter, whack it into the density calculation to do density times volume, and that's going to give us the mass of 7.458 grams. Now turn the mass of Hex1ene into moles. So you're going to use your mole equation, which is mass over mR times moles. So you need to find the mR of Hex1ene. So it's going to be C6H12. And if you add that up, that's 6 times 12 plus 12, you're going to get 84. And if you divide your mass by 84, you're going to get 0.088785 moles. I put an N for number of moles. Now there's a 1-to-1 ratio between the reactant, which is the Hex1ene, and the hexane-2-ol. So that means if we have 0.088785 moles, we should get the exact same amount of hexane-2-ol. So we should have 0.088785 moles of hexane-2-ol as well, in theory, if everything has gone perfect with our experiment. So now we want to find out exactly what mass that will be. That's going to be our theoretical mass. So we're going to do 0.088785. We're going to stick it in the mass equation. By timesing that by the MR, we're going to work out the mass. Now the MR of hexane-2-ol is going to be C6H14O. Okay, and we're going to get 9.056 grams because the MR is 102. So we times the moles by 102, we get 9.056. So we've just worked out the theoretical mass and we know the yield. So we just need to rearrange that equation to work out the actual mass. So 31% is going to be equal to the actual mass over 9.056 times 100. Of course, you can divide both sides by 100. Personally, when you're timesing by a percentage, you know 31% is 0.31. So we're just going to do 0.31 times the theoretical mass, which is 9.056, and you get your answer, which is the actual mass. So 0.31 times 9.056 grams, you're going to get 2.807 grams. We're going to lose a mark unless we check this here, one decimal place. It's always easy to miss that, so you should use a highlighter. So it's 2.8 grams to 1 dp, and that'll get you 4 marks. Boom. Hope that's been helpful. Subscribe, hit the like. Let's get to the marks.
You're still here? It's over.